Exponent laws. Exponent laws help us simplify expressions that have powers with the same base. We're first going to cover the product rule. So step 1, when multiplying powers with the same base, you're going to add the exponents. Step 2, if the coefficient of the bases is not 1, you multiply the coefficients. So here is the property. So here we have the same base, x, and x in both terms. So we have x and x with different exponents. Here's a, here's b. They could also be the same. You add the exponents. So a plus b. So let's apply that to the example to the right. So we have an example 1 here. 3 to the power of 2 times 3 to the power of 5. The base is the same, 3 and 3. So we're just going to add the exponents. So 3 and then 2 plus 5, which is further simplified to 3 to the power of 7. Now let's look at example 2. We have mn and mn. So we have two different bases, variables. So we're going to highlight here so that you can see them more easily. So m, and then n to the power of 6, n to the power of 8. So we will write m as the first variable, and then look at the exponent 5 plus the exponent here, which is 4. So 5 plus 4. And then the next variable, n to the power of 6 plus 8, which is further simplified to m to the power of 9 and n to the power of 6 plus 8, which is 14. Now, if the coefficient of the term is something other than 1, so it's not equal to 1, for example, in example 3, we have -4 and 2. We have x and we have y. So we're going to multiply. If coefficients are not 1, you will multiply the coefficients. So -4 times 2. And then your next variable is x, and you're going to add the exponents. And the exponent here is imaginary 1, the invisible one, exponent rule. So it's x to the power of 2 plus 1. And then y, 3 plus 5. So now I'll add them together or multiply the coefficients. It equals to -8, x to the power of 3, and y to the power of 8. Now we're going to look at some examples. So question 1 asks, simplify the following exponential expressions applying the exponent rules. Then evaluate if possible. So for question number 1, I'm going to zoom in a bit. We have the same base, h and h, so we just have to add the exponents. So it is equal to h, 3 plus 5, which is equal to h to the power of 8. In example B, we have two variables. We have a base of j and k. So I'm going to add the exponents of the j's together and the k's together. So j to the power of 3 plus 6 and k to the power of 4 plus 2, which is equal to j to the power of 9 and k to the power of 6. For example C, we have 3 terms, and all the bases are the same, a 2. So we just have to add the exponents together. So 2 to the power of 2 plus 3 plus 2, which is equal to 2 to the power of 7, which is equal to, if you evaluate it, 128. So let's say, example D, we have now coefficients and a. So we'll highlight the coefficients and the variable a. So 6 times 7 is 42. And then a to the power of 4 plus 2, which is equal to 42a 6. Now I'm going to look at example E. So we have 3 terms here. So we're going to multiply all the coefficients together. -5, -6, and 2. And then add the exponents of the base y. So -5 times -6 times 2 times y to the power of 2 plus 3 plus 5, which is equal to 60 y to the power of 5, 10. So we're going to look at example G. In example G, we have the coefficients of 5 and 3. A is another base, and then B3, B5. So 5 times 3 times a to the power of 4 plus 2 times b to the power of 3 plus 5 is equal to 15, a to the power of 6, and b to the power of 8. We're going to look at example H. So H has 2 coefficients, 2 terms with the same coefficients, -2, -2, x, x, and a y. So I'm going to multiply the -2's together. And then x to the power of 1 plus 5. There's an imaginary 1 there. And then y to the power of 2 plus 3, which is equal to 4, x to the power of 6, y to the power of 5. And finally, I, the coefficients are 3 and -4. And then there's the base of x and y to the power of 3. So we'll multiply the 3 and -4 together. Add 7 plus imaginary 1. And y to the power of 3 plus 8, which is equal to -12, x to the power of 8, and y to the power of 11.